Hello, it's Keith here, and this is lesson 59 of the platform-specific series of my 68,000 assembly programming tutorials. We are looking at interrupts today. We are using the Amiga, and we are going to install a VBlank interrupt handler and use it to time some music. So we've got some music playing on my previous example. This is the min-tile example, a graphical example. It's been extended with music, so we've now got a combination of sound and graphics just to show we can do both at the same time. Now, what we're going to do is we're going to use the operating system. We're going to hook into the operating system and install our own interrupt handler, and that is going to basically control the timing of the music so that the music plays at a constant speed. Now, the music's being played by my ChibiTracks player. This is a multi-platform player. We're also going to take a quick look at that just to sort of round off the tutorial. Okay, well, let's get over to the code. Let's take a peek. Okay, so this is the file we're looking at today. We're looking at AMI min-tile blit with sound. So we've added this to our blitter example. So basically, how do we use the interrupt? Well, as I say, we are using the operating system to actually do the job of controlling the interrupts. So what I've done is I've created a subroutine called install interrupt handler. And this is actually doing the job of setting up interrupts on the Amiga, because as I say, we're talking nicely with the operating system and getting it to do the work for us. So here is the routine itself. Now, basically, we are going to use one of the system functions. We're going to use the function exec add int server and to add interrupt server. And so we're going to need to send this to the operating system. So we're going to get an operating system pointer. We do this by loading in a long from memory address 4, yes, that low, into A6. Now, basically, this is loading the address of the OS pointer. So now A6 points to the operating system pointer that we can use. Now, what we're going to do is we're going to use the function -168, which is exec add int server. So we just use that as an offset from A6, and we're going to jump to that. But we need to load some parameters. Now, there are two parameters we need. The first one is the pointer to a structure that defines our interrupt, not the interrupt handler itself. Here is the interrupt handler. We're going to take a look at that in a moment, but we need to actually create a structure which actually defines the sort of details of that interrupt handler that we pass to the operating system. So we load that structure into the address register A1. We then load into D0 the interrupt number that we want to use. So that needs to be a 5. Now, interrupt 5 is int b vert b. That is the VBlank interrupt. So that, for this example, would be constant. And so all we need to do is basically, have the correct structure, and we would just need to change that structure according to what you want to do. Okay, so let's take a look at the structure that we need to pass. So there's a couple of bytes. Now, there's two longs to start. Now, these we're just defaulting to 0, and I think these are basically, it's a doubly linked list, so there is a previous and a successor one, but we're defaulting those to 0, and maybe the operating system is loading some new values into those. I'm not really sure what it's doing with those, but we just leave those as a constant value there. We are loading a type. We need the type to be NT interrupt, and that is a value of 2, so we're loading a 2 there. And there is a priority, and we're giving it the value 127. Now, these are fixed values. Basically, we would just leave these the same. These I copied in from from one of the manuals for the Amiga, so I don't think you should need to change those. Now, we apparently give it a name. We need to give the interrupt a name. So we basically need to give it a 0 terminated string here. So I've just called it my interrupt. I'm not sure where this gets used from that point of view of sort of our programming. I don't see any way we'd ever see this. I don't know if it's sort of, if you were using a more advanced operating system, you might be able to see a list of the running interrupts or something. But anyway, we have to give it a name. It's part of the definition, so I've just given it a generic one here. I guess you might want to change that if you have need. Anyway, the other things, the thing we definitely need is the address of our interrupt handler, which is the second one here. The first one is the pointer to a data structure. Now, our interrupt handler actually does the job of the updating the music in our case, but we can pass a structure to the interrupt handler, and I guess this would be really handy if you had multiple interrupt handlers that all did the same thing. So you wanted to have the same code, but we're going to work on different sources of data. I don't think we would want to update 2 pieces of music at the same time, but maybe if we were using VBlank to update sprites or something, maybe we would want to have different pointers of different sets of data structures for the different sprites we might want to update, and then we could install multiple interrupt handlers. It would be for something like that, but for my purposes, I don't really need it. We have to specify something for IS data though. So I'm specifying a pointer to my data, and my data is just here, and it just contains a long with a value of 0. Now we're going to play with that just as a little test, but as I say, if you were just wanting to have your own interrupt handler and just one VBlank interrupt handler, all you really need to do is to maybe change this interrupt handler thing here, or maybe just copy all of this as is. It will work just fine. The only thing I would sort of say is, I guess, you know, if for safety, maybe you want to give my data some kind of valid data, not just point it to some random memory, because I guess that could cause some problems if you forgot that's what you've done. Anyway, onto the interrupt handler itself. Now, when the interrupt handler executes, A1 will point to the structure of the data that we passed in IS data, which in our case is my data. So what I'm doing is basically I'm adding 1 to that. Now, in the case of our example, you saw the computer control character was moving horizontally across the screen, and that is because I've actually loaded in the X position of the computer controlled character from my data. Now, if I rem out this line here, the computer controlled character will stop moving and we'll actually never see it even enter the screen. And so that was just me testing that my data was actually being passed in A1, and it indeed is. Now, A0, a bit weirdly, needs to retain the value shown here. Now, that's just something to do with the operating system functions, but that is fine because actually we're backing up all of our registers here with a push and a pop. Now, the operating system itself doesn't seem to actually care about D0 and D1, so I'm not backing up or restoring those. I guess it's backing up and restoring those by itself, but for the rest we are preserving and restoring them there. Now, our interrupt handler itself, to update the music, all we need to do is run ChibiTracks play. That actually does everything. It reads in the music file and works out what needs to be done next, updates the hardware accordingly, so that's all being handled there. The other thing that we do need to do, though, when we return from the interrupt handler, we need to tell the operating system to continue processing the other interrupts. And the way we do that is we set the Z flag, the 0 flag. And so the way we're doing that is we're simply moving the value 0 into D0 here. That effectively sets the 0 flag, and then we return. So that's all we need to do. Now, I think if we didn't set the 0 flag here, that would actually stop the other interrupts from occurring. I don't know if we would want to do that. I guess if we know what those other interrupts would be and we have decided that we are more important than them, we might want to do that. But anyway, so for proper behavior, we are setting the 0 flag here as we return. And that's all we need to do for our interrupt handler. So as I say, basically, if you are looking to use interrupts on the Amiga, all you need to do is basically copy this one template here. You can use this as is, you can use this as is, and you can use this as is and just replace this part here or this part here as appropriate. And as I say, basically all of these parts here are sort of translated from an example that I saw in one of the Amiga reference manuals. So you can see I've even put a reference to the page number I've used here, so that if you want to go and see it, you can go and check out the source material. So as I say, hopefully this is correct to specification, so to speak, and it should work fine for you. So that's how you can use the interrupts. And now what we're going to do is just quickly discuss the ChibiTracks and the sort of changes I made to this code to get ChibiTracks working. Now, what does ChibiTracks need? Well, firstly, it needs a music file. Song 1 is the music file here, and this is a binary file. This CBT is a binary export from the ChibiTracker Pro Windows software. Now, the important thing about ChibiTracks, the purpose of it, is that it can play a single binary file on any system. So this binary file was exported and originally played on the Amstrad CPC, a Z80-based system with an AY sound chip. But we can also run the same, play the same binary file on a 6502-based system like the NES, and we can even do it on the 68000 Amiga system. It will play in roughly the same way on all the systems without re-exporting the binary file, so it's going to reduce your programming time. That's the plan of it. Now, ChibiTracks does need a few things. It needs a platform-specific driver. That is Chibi Sound Pro. That's what it's called. It's satirically named based on the Sound Blaster Pro. It's a bit of a parody there, the title. That is the platform-specific driver that handles the peculiarities of each system. So that is platform-specific. The rest is all multi-platform and is consistent for all of the systems on this CPU type. So ChibiTracks is the player itself. That is basically the software that handles the loading of the bytes of the song and working out what needs to be done next and passing those commands to Chibi Sound Pro, which actually does the platform-specific stuff. Then there's two shared functions here. ChibiTracks Tweener and Fraction 16, they do the in-between notes where you've got sort of two notes, but then you've got flats and sharps and various in-between shifts. I split those out into separate modules because I wanted to reuse them later on, and I was hoping maybe I could find some tweaks and optimizations I could make. Maybe I could come up with better versions later on. So I split those out into separate modules. Anyway, that's the source code. That is the song file. The other thing we need is we need a little bit of memory for ChibiTracks and Chibi Sound. On the Z80 systems, it was only 128 bytes. On the 68000 systems, because of the longer address registers, we are using 256 bytes. So we're just defining some RAM here in the chip RAM section here. So that's the base memory we've allocated there, and we've got some pointers to some of the variables within that block there. These are variables that are used by the player itself. We're just defining them, sharing them with the Chibi Sound RAM there just for convenience. We don't really need to use those in most cases, but we can play with them in some cases if we want to. So how do we actually get music started? It's very straightforward. First, we one time only initialize the sound driver for this system. Chibi Sound Pro init will do whatever is required for the system. In the case of the Amiga, it's sort of setting up the various registers of the sound hardware and things, and on systems like the Super Nintendo, for example, it's having to load a whole sound driver onto the separate CPU, so it's very platform specific. Some systems it does nothing at all. Now then what we're doing here, and this is what we need to do every time we want to play a new song, we're loading the address of the song we want to play into Songbase. Songbase is one of those variables within the player's memory area. And then what we're doing here is we're running start song. So you do that every time you want to start a new song or restart the current song. Now, what we need to do after that is simply update the music as part of the interrupt handler. So that play routine you saw before is the last thing we need to do, and we just need to do this regularly to update the music, hopefully at constant speed, in this case via an interrupt handler. If you had just had a simple title screen though, you could just use a crude loop as a pause. Whatever is required, as I say, you just need to make sure you update it at constant interval to make the music play well. Now, one final thing you may want to do is you can actually override the speed. So on some systems, I'm changing the speed and making it a little bit slower. For the systems that the interrupt to 60 Hertz, because this song was written on a 50 Hertz system. But we can also do things like make the music super fast. I always refer to Super Mario. If you remember in Super Mario Brothers, when you're running out of time, the music gets really fast, and that's just to make the player hurry up or maybe make them panic and fall down a hole. But we can do the same here. We just change the default speed. The default speed is 5, but if we change it to 3, it will play faster. And if we changed it to 12, it would play slower. So we can override the song speed, and that's the use of one of the variables there. The other ones, to be honest, we don't really want to mess with. Song channels is loaded in, and song base. These are all loaded in and calculated automatically on this system when we run that start song. So we don't really need to change those variables. We just need to allocate them some memory. Anyway, that's all for today's example. As I always say, go to my website and download the source code and the build scripts, and with all of the tutorials, but specifically with these, I would say I don't imagine that they are particularly amazing, but you are welcome to use them in your own projects, even if they're commercial. I just like to say that just so you can get the full advantage of them, whatever it is. But as I say, they're really just intended as hobbyist projects, but make any use of them you can. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.